In this video, we're going to start working with secants, and what we're going to focus on here is what's called secant secant angles. So first off, what is a secant? A secant, by definition, is simply a line that passes through the circle in exactly two locations. Okay? So pretty simple. Notice that a little part of the secant would be called the chord. And we could have a secant that goes through the center, making that little segment a diameter. All right? Now, a secant secant angle is formed when you have two secants. Okay? So two secants that connect. Where they connect, we're going to call that location the vertex. When we have a secant secant angle, there are three scenarios that we're going to investigate. One is when the vertex is on, one when the vertex is inside, and one where the vertex is outside. So let's start with the vertex on, okay? So I have a scenario that basically is going to look something like this. I have a secant and another secant that have a vertex on the circle. Well, if you look at this secant scenario with the vertex on, we've already studied this. This is known as an inscribed angle. If I just look at its segments, you can see by that red outline there the inscribed angle. And what do we know about an inscribed angle? We know that an inscribed angle has an intercepted arc, and we know that the angle is half the arc, or conversely, the arc is 2 times the angle. So when we have this secant secant vertex on scenario, we really don't have anything new to learn. We just have to remember that the angle, so I'm going to call the angle here 1, and we'll call this arc A. I know that the measure of angle 1 is equal to half of arc A. Or conversely, we know that arc A is equal to 2 times the measure of angle 1. All right? So let's apply that scenario here. In the first picture, I have a secant secant, but the vertex is on. So I know if the vertex is on, the angle is equal to half its arc. And again, remember, for those of you guys still having a little trouble with this, there's our angle. Here's its arc. The angle is equal to half the arc. So therefore, what do we know? We know that the missing angle is 80 degrees. All right, let's bring a variable into the mix. Well, here's the angle. I notice right away vertex is on. So if the vertex is on, I know that the angle is equal to half the arc. Let me rewrite that 12 a little bit better. The angle is equal to half its arc. Okay? So that's what our definition says. Now, I don't want to distribute that 1/2. Instead, I'm going to kind of vary or use what we talked about before, which says 2 times the angle, 2 times the angle is equal to the arc. So this tells me that 20x is equal to 21x minus 12. Subtract 21x, negative 1x is equal to negative 12, or x is equal to 12. All right, let's take a look now at scenario number 2. Scenario number 2 is a secant secant vertex in. All right, so I've got a secant. Just draw a line through it. And I've got another secant that cuts through the circle. And notice now my vertex is inside. Now, at that vertex, there's actually 4 angles being created. Okay? Watch what happens. You have to focus on the one angle that they want you to find. So let's call this angle right here angle 1. All right? And that angle would kind of be, I'm going to just highlight it here in red. They want us to find that angle. All right? Now, this is the tricky part. This angle has this for an arc, but it also has the back side of the angle as an arc as well. Okay? So this angle has arc A and arc B. Here's what our property says when vertex is in. I know that the angle is equal to half of the arcs added together. All right? Half of the arcs added together. So that's this first scenario right there. Another way that we can look at this would be to say 2 times the measure of angle 1 is equal to the arc plus the arc. All right? And that's that second scenario for how to write it. It doesn't matter whether you write it in red or whether you write it in blue. You're going to find the missing piece the same way. And just a little heads up here, guys. What we're learning today, you're actually going to be practicing today, the next day, and the day after that. So this all goes together. It takes a lot of practice if you're having a little trouble at first, okay? So let's take a look at our examples here. I recognize vertex is in, okay? There's the angle that they want me to find. I know that angle has these 2 arcs that go with it. One on the front side, one on the back side. Okay? Our rule says the angle is equal to half of the arcs added together. Now, when I add these together, it doesn't matter what order I add them in. Okay? Now, for this particular problem, you know what? I'm going to solve it the way that it is. So I know that the question mark is equal to half, and I'm going to add these 2 together and get 160. Half of 160, I know is 80. So that missing angle in that picture was 80 degrees. Okay? Now, take a look at this second scenario. Here's the angle that they want me to find. All right? It has this arc and this arc as its 2 intercepted arcs. So for this one, let's see, I know that half the angle, oops, sorry, I messed that up. The angle is equal to half the arcs added together. So I'm going to take 17x minus 1 and add to that 154. The angle is equal to half of the arcs added together. So in that scenario, I think what I want to do is I want to reverse that 1/2. Get that out of there. And I'm going to rewrite this as 2 times 35x minus 3 is equal to. Now I move that 1/2 over to the left as a multiplication. But over here on the right, I'm going to combine these like terms. And it would be 17x plus 153. I'm going to distribute the 2. 70x minus 6 is equal to 17x plus 153. Subtract 17. So let's see, if I subtract 17, that gives me 53x minus 6 is equal to 153. Add 6, 53x is equal to 159. And divide by 53, I get x is equal to 3. All right? Notice how the 2 ways that I told you to do these, this was one way, this was the other way. The second way made more sense to help me to solve because I didn't have to deal with any fractions. Okay, Scenario number 3, secant secant, vertex out. So the vertex for this one is going to be on the outside. Let's say that we have a secant like this, and let's say that we have another secant that comes like this. All right, and let's say that our angle is going to be that angle, or you know what, let's take that off. Let's make it this outside angle. They're both going to be the same because vertical angles are equal. All right, if that's the angle, then I know this is an arc and this is an arc. Those two arcs go with that angle. I'm going to call this arc A and call this arc B. Now, looking at the picture, would you say that A or B is bigger? Hopefully you recognize that B is the larger of the two arcs. That is going to be very important as we write our equations. So here's our first one. The first one says the measure of angle 1 is equal to half of the arcs subtracted. Notice that. Half the arcs subtracted. Well, we don't want to get a negative measurement for our angle, so I want to make sure that I take arc B minus arc A. Bigger minus smaller. Now, sometimes that's going to work nicely with that half, but sometimes we don't want to deal with the half, so what I'm going to do is take 2 times the angle, and that's going to be equal to the arc minus the arc. There's our second scenario for how to do the secant secant vertex out. All right, secant secant vertex out. The angle is equal to half the difference of the arcs, or 2 times the angle is equal to the arc minus the arc. One of those two has to be applied for the secant secant vertex out. So let's take a look here. In this first one, notice that angle is our question mark. I know that the angle is equal to half of arc minus arc. Well, let's see. There's one arc. There's the other arc. I have to subtract them, and I know that I want to take 155 minus 59. Why? Because if I subtracted 59 minus 155, I get a negative number. I can't have a negative angle. So in this problem, we're good to go. I have the question mark is equal to half of 155 minus 59. Let's just double check my arithmetic. 155 minus 59 will be 96. And half of 96 would be 48 degrees. All right, what happens if they throw variables in there? Not a problem. There's our angle. I know that the angle, 2x plus 19, is equal to half of arc minus arc. Now in this one, I'm going to take 155. Sorry, forgot to highlight our arcs here. I'm going to take 155, that's the bigger, minus 5x minus 9. Notice I subtracted both of those pieces. Very, very, very important. It's just like you're distributing a negative 1 to 5x plus 9. Now, I don't want to have to deal with half of those numbers over there. So what I'm going to do is double the left side. So 2 times 2x plus 19 is equal to, let's see, 155 minus 9 would be 146 minus 5x. I got to distribute. 4x plus 38 is equal to 146 minus 5x. I'm going to add 5x, so that would be 9x plus 38 is equal to 146. I'm going to subtract 38, so 9x would be equal to 108. Divide by 9, that gives me x is equal to 12. I hope this makes sense. Do your best. I understand it's going to be a little tricky. That's why I didn't give you a whole lot of problems to do here. Do your best. Let me know if you have any questions. I'm happy to work with you.